Okay, welcome to the notes on 6.3 absolute value inequalities. So it's just like the equations we solved in 6.1, but now we have inequality signs. So that changes our solutions drastically. So let's review. This was 2.6 compound inequalities when we had that and the or in between these. What did we do when we had that? Well, we just went on and simplified our equations first. Remembering when we divide by a negative, we do flip the sign. It's going to happen a few times today. So x is bigger than 3 or x is less than minus 1. If you remember what we did when we were in that unit, we had 3 number lines. And what we did is we graphed, to say this is 3 and this is minus 1. We went ahead and we graphed one of them on each line. Remembering that open circle is for when it's strictly less than or greater than. And we had open circle here. And then when it was or, that means one or both. Keeping in mind that this is really the solution. And I'm going to graph that down there on that graph, that number line. And remember that and simply just means both. So when I look, this is again back in 2.6, when I look at those two inequalities, I say, okay, my solution is going to be where I either have one line or both lines. And we divided it up vertically like this. Remember, this was probably like 2 or 3 months ago. This one is included and this one carries down because that is where one of the inequality lines is there. You know, I could have maybe another one here, but one or both is the minimum requirement. So basically it ends up with or, you just slap down both of the inequalities is usually what happens. So the answer is simply just putting both of those individually on there. So that's the typical or, they go in opposite directions. And that's what we'll see for us. So we're only really concerned with ones that look like that. And is a similar type of game. We will first solve, so that step's the same. And when we picture that, you know, so or is going to always have like this sort of picture, but and is always going to be like a little segment is the way that these pan out this time. So what we'll do is we'll put a point at 1 solid, put a point at 5 solid, and then if we're bigger than 1 and less than 5, it would be this segment here. So and is going to be a segment for us, and or is going to be 2 different possibilities. Okay? So, and then remember what we said from 6.1, absolute value is, the absolute value of a number is its distance from 0. So we see that in the nice picture next to it. So if we want to graph this is red. The distance from 0 is greater than or equal to, which I guess I'll write that out, greater than or equal to 2. So if we have 0 right here, and we go out a distance of 2 in either direction, this inequality is saying, hey, only include a line where the distance is bigger than 2 or equal to it. So it starts right here, and it continues on. So every single point in here, you know, on the line, all these points, they all agree with the same thing, that the distance from 0 is bigger than or equal to 2. Okay? That's with the greater than sign. So we're seeing right away that a greater than sign, either one of these, that kind of has that or look to it, where it's 2 separate ones, one or the other. This would be the distance from 0 is less than 3. So here's 0. This inequality, an and inequality, is going to look at just containing the points that are within 3 of 0. So all of these are included. They are within 3 of 0, and we do not include 3 since it does not have the underline, and it goes on this way too, backwards. So all of the points contained there are within 3 of 0. Okay, so it's about distance. So now we're kind of seeing, okay, these signs might mean that we have an and look. And that's exactly true. So our big idea here is that absolute value inequalities with a greater than, they turn into or compound inequalities. Because it branches, it's this one. It branches into 2 different paths, which we use or for. Whereas the one on the right, they're joined together. So this would be an and. Okay, so we use this so much that I've heard a nice like mnemonic to help us remember these things. So when you have a greater than sign, we say greater than, right? Greater, it's or. And with less than, it's less than. So when we have a greater than sign or a greater than equal to, or less than equal to, that's what we pick to join together the 2 inequalities. And you'll see that here in a second. And when we do break it up, the inequality sign is going to flip. But I'll tell you where to look out for that. But so this box is a good summary of what today's about. So the first step to solve and graph would be to first isolate the absolute value piece. Definitely. And then we look at the sign and we say, hey, is that a less than sign or a greater than sign? And it is a greater than sign. So we're going to think greater. So the or is going to join these 2. How do you break them up? Well, you just copy and paste here. So this is the positive branch. The negative branch, because remember for 6-1, we just broke it up into like equals 4 and equals -4. And we do the same thing here, but we do have to flip the sign. So this is what that was talking about at the end of the table up here, right here. So not only does the 4 change to a -4, the sign flips as well. So it's actually a flip here and then a flip of the sign here. So it's a flip and a flip. You see that? Once you have that, we're just going to go ahead and solve for x. And once I get down to the bottom, I like to rejoin that or, so I remind myself that I want to be graphing an or. So those are my 2 equations. This here is the written answer with the or. You need the or there. And if I want to graph this, I would first plot my 0 and my -4 with solid dots because we have the underline, we have the or equal to. And I'm going to look at my inequality signs here and here as my arrows that are going to point to where I need to go. And it's an or, so it should be 2 separate ones. So x bigger than or equal to 0, it points me this way. And by point, I mean this arrow matches this arrow right there. That's a little hack that we use. Less than -4 would be going more negative. Okay, so that's the answer. So you'll either have this look, and it's an or question, or you'll have an and it's going to be just a little segment. So this next one, we're anticipating this might be an and. So the very first thing I'm going to do is I want to rewrite the first line. I want to multiply both sides by 3. The best thing to do with the fraction is to just clear it right away. So multiplying by 3 over here and over there makes this a lot simpler for us. This is a less than sign, right? So this breaks up into an and. So we have copy paste here, the positive branch, and we also have the negative branch, which not only switches the sign there, but it also switches the sign here. So there really is a double flip here. You got to flip both, the sign and the negative sign. You swap it. Okay. So now I'm going to go ahead and solve for x, which is pretty easy here. And we get this. So what does that mean? Well, it means that x, so we got 2 and negative 2, open circles, right? And if we read this, it says that, hey, x is less than 2, but it's bigger than negative 2. So it's this chunk here. And by the way, if you do have an and that's a line segment like this, we can rewrite it like this. This is another equally great way of writing the answer. The way you do it is you kind of take this one. The best I can show you is you almost flip it like this and put the x's in the same spot, and there you have it, right? So we're not changing the inequalities at all. We're just joining them in a different order. So anyways, that was kind of fun. There you have it. So things aren't always so great, though. We took some stuff for granted here. So let's take a look when something isn't so nice. And what's cool about this is if we have an eye for it, we can spot it real fast. So I'll tell you what to look for. First, we're going to solve, which actually does flip a sign. Very important. Okay. So what's happening here? It says an absolute value is less than negative 5. An absolute value, like whatever you get from that, is less than negative 5. Guys, this is impossible. Impossible. You can't have an absolute value come out to be negative. I mean, this is saying, like, here, let me just write it out. Because this quantity, whatever that might be, I have no idea what that is, but I do know that it is positive. Absolute values can't come out being negative. Okay? So, because it's positive, it cannot be less than negative 5. Because if you're less than negative 5, you're negative, right? So it doesn't work. So this one is one of our no solution scenarios, because it is impossible. And both of these cases here, they hinge on the fact that absolute value is always positive. So even though this looks like a kind of a mystery right now, we always know that that's positive. And a positive number can't be less than negative 5. So that's the logic for why we have no solution. Okay? So no need to graph anything. It's just no solution. Similar thing over here. I'm going to move the 11 over, and I get a negative again on the right side, which is really the root of all of our problems. How do we reason through this? The only difference is now the sign is in a different location. We still have a negative, but now the sign's different. So this one is always true. Because whatever this absolute value quantity is a positive quantity. I don't know what it is, but I know it's not negative. I know it's positive. And because it's a positive number, it is always larger than -4. Right? A positive quantity is always larger than -4. So this statement is just a true statement. No matter what you pick for x, you can be as creative as you want. The output is going to be positive, which is definitely bigger than -4. So this is a infinitely many solutions, or you could also say all real numbers. Basically, x can take on whatever you want. No matter what you put in there, absolute value is positive, so it'll be bigger than -4. I can guarantee you that. So this is the other end of the spectrum. So the problems happen when we have a negative right here, and right here. That's the issue. With the ones we did before, they were positive. You see? So that is the problem. And that's the problem too when you're checking solutions from 6-2, when you have to check for those extraneous solutions. The issue happens is when the right side's negative. All right? Cool. And then really quick here, we can use that same formula to generate a equation from a picture. So it is the same idea. If we find the midpoint and the distance between the points, we can write the equation. So let me show you what I mean. So 2 is right in the middle. This is the midpoint. And the distance to the points that resemble x in both directions is 3. So the way this works is x minus the midpoint, and then you have to pick a sign. So remember, this kind of setup is or, and this kind of setup, whatever, filled in, not filled in, doesn't matter, that's and. So this looks like an or, but an or is a greater. So we're going to use a greater than sign, and I'm going to put a line under it because they're filled in. So this is our less than. So having a good idea of those visual, this right here is really key. Make sure you write this down somewhere. Because this next one looks more like an and. It's joined together. So the midpoint looks to be, just eyeballing it, right here. And the distance to the open circle is 4 in both ways. So using this idea, but we don't use the equal sign, it's going to be minus -1, and the distance is 4, but it's an and. It's got the and look. So it's going to be less than. And since we have open circles, we're going to leave it like that. Okay? And now you have plenty of homework to work on. If you have questions, you can always consult the key and you can see what those answers are. But definitely try these. Working on that homework will be enough for you to do well on this when the test comes up.